Okay, I had another question through email about how to solve this third degree polynomial equation. If it's something you want to try now, pause the video, try it, and see if you come up with the same solution. But when we are given a higher degree polynomial equation like this, the first thing we want to do is see if we can do any factoring. And the fact that this is a 4-term polynomial tells me I should try grouping. When you attempt grouping on this, it fails though, and it doesn't work. So you have to move on to another process. So if you can't get it to factor, you look to find a root on your calculator. There is a way to find the possible roots using something called the rational root theorem, which you may go over in pre-calc, but in Algebra 2, what I always do is just have you use your technology, which is your calculator, to help you find your root. So on my calculator, I'm going to put in the equation here. 3x to the third plus 4x squared plus 4x plus 3. And I'm going to go to the table. And the table is going to tell me some of my roots. So let's go to second table. Pull up the table. We're looking for places where y is equal to 0, because that'll tell us that we have a 0 or a root. And there it is right there. Right there at -1, we have a y value of 0. So -1 is one of our roots. So that gets us started. -1 is a root, which means x plus 1 is a factor. So how do I figure out the next piece of this factoring? I take this -1 and I do synthetic division using my original equation. Put my coefficients in, drop the 3 down. -1 times 3 is -3. Add those up, I get 1. -1 times 1 is -1. Add those up, I get 3. -1 times 3 is -3. Add those up, and I get 0. I should get a remainder of 0 because -1 is a root. So what I've now figured out is that since one of my factors is x plus 1, and when I did the synthetic division, I got these 3 numbers, which are my new coefficients on my other factor. Remember, this was a 3rd degree polynomial, so I knock it down to a 2nd degree, so it's now 3x squared plus 1x, or just x, plus 3. And this is all still equal to 0. Now I look at this polynomial, or this trinomial right here, and I see if maybe I can factor that now. It's a trinomial whose a value is 3, so I'd have to try AC. AC does not work. So since AC doesn't work, that means this doesn't factor any further. So my solutions are x equals -1, and this solution right here is going to come from using the quadratic formula. So I now have to plug into -b plus or minus the square root of b squared minus 4ac all over 2a. That's going to give me -1 plus or minus the square root of 1 squared minus 4 times 3 all over 2 times 3, which is going to give me -1 plus or minus the square root of, let's see, that's going to be 12, 36, -35 under there, which means I have some imaginary roots here. That's going to give me a 6 on the bottom. The only thing I can do here is pull the I out of the -35, and there is no other reducing that I can do there. So there are my 3 solutions. X equals -1, and then I have -1 plus I radical 35 over 6, -1 minus I radical 35 over 6, giving me a total of 3 roots, which makes sense because this was a 3rd degree polynomial.